It's Maker Advent, Day 1, 2023, and it's the same format as always. Every day from here until Christmas Eve, I'll create a video and release it on YouTube of me taking some piece of electronics tapped from the pound store, the dollar store, from Team U this year. I've been to Team U, not AliExpress as normal. We'll have a look at it, see how it works, take it apart, can we hack it, can we play with it. I've also got something very special this year. I've got something donated from Pocketmoneytronics, and it's a trio of trees. So here's a trio of trees. There are 3 Christmas tree shaped PCBs connected to Raspberry Pi Pico, not included. If you're going to get a Pico, get a Pico W, which is what I've got. It'll make sense in a minute, but you've got Wi-Fi and Bluetooth. Well worth £8. This kit is £10 from Pocketmoneytronics. Good bit of fun. You can solder the connections yourself for the Pico. The trees come pre-soldered. It's all SMD soldering. I love it. It's fun. I have had some fun. Also, Banana for Scale is now 3D printed. It will not go off, hopefully. So these Christmas trees are set to show numbers between 0 and 14 officially. So 0 down here, 14 over there. And it can show whatever we want with them. We can just have a pretty light show, or we can do something a bit cooler. So the paperwork that comes with it, the pamphlet, comes with some code snippets to try out and have a go. Good fun. What did I say? £10. You can get it from the shop. I'll put a link in the description. Yeah, YouTube, I remembered it. You can also, if you live in Cambridge or near the area, you can go to the Raspberry Pi store and pick up your own from there directly. I wanted to do something different with it. So rather than just having lights flash on every day, I wanted to show what day it was in the month leading up to Christmas Day. So day 1 to day 24, but then 25, something special. This is the code for day 25. It shows off all the LEDs flashing. But the problem is, there's 14 LEDs, but there's 24 days leading up to Christmas. We need more LEDs. We haven't got them. So how do we do this? Well, a little bit of simple ingenuity. We've got the numbers printed on here, so we can just say, okay, when it gets to 15, just show 1 and 5 lit. Have them flash. 16, 1 and 6. 21, 2 and 1. I'm a bingo caller now. So, how do we do it? Well, we're going to use MicroPython, and we're going to use something called NTP, Network Time Protocol, which basically says, okay, get me online. So Pico W has Wi-Fi, get online, connect up to this NTP server, and it'll say, hey, what's the exact date and time, please? And it'll give me those details back as a tuple. Was it a tuple? Can I remember how to say it? I'm going to say tuple. Returns those details back as a tuple, which I can then use in Python to say, right, slice out the day. So is it day 1, day 2, day 3? And then we use that to control that numbered LED. So here is the code. You will see that the Wi-Fi details have been anonymized to protect the innocent. We start off with 4 imports. Import network, import time. So networking, get me on the internet. Time, control the pace and speed of our code. NTP time, to go online and get the time. And from machine, import pin. Import the pin class from the machine module so that we can use GPIO. All of these modules are pre-installed on the Pico. No installation necessary, just they're ready to go. Just follow the guidance on how to flash MicroPython onto your Pico and you're away. Okay, so we create an object called WLAN, wireless networking, and then we turn that connection on. We then connect to our Wi-Fi access point with our SSID and password. Then we sleep for 5 seconds. You don't have to sleep, but you've got a better success rate if you let it sleep a little bit after connecting, otherwise it can report false. False connection means I'm not connected. True connection means connected, which is what it prints here. We then get the current time and date and save it into an object called date. That's going to be the tuple. And I'm going to slice out of there the day. I don't want to know the month, don't want to know the hours, anything, just the day. Is it day 1 of Advent, day 2, day 3, etc.? Next bit is a function. This function's job is just to clear the LEDs. I don't want any LEDs to be on when it starts up. The function just uses a variable called I, set to 0 to start with, and a for loop which iterates over 26 times, so 0 to 25, and sets the GPIO pin with the value I, so it starts off as 0, then 1, then 2, then 3, then 4. It sets them all as low. That function done, we go to the Advent function. This is our Advent calendar. This takes an argument of n. N is going to be the day. We can actually put day in there, it doesn't matter. I just put n because I'm really lazy. If n is less than or equal to 14, so it's one of the LEDs that's on the board, so already there, just print the value to the screen, so Python shell, set the appropriate GPIO pin to be an output and set it high. Wait for a second, that keeps the LED lit for a second. Then turn the LED off, wait for 0.1 of a second. Now this code will automatically loop round and round. We're going to use a while true loop later on. So just keep flashing the LED. All the way up to 14 is easy. That's all contained in there, so 0 to 14, easy peasy. So now we go to between 15 and 25, because 25 is a special day. If n is 15, print the value to the Python shell. So we're on day 15 of Advent. It's going to turn pin 1 and pin 5 high, so turn them on, wait for a second, then it's going to turn them off, and wait for 0.1 of a second. And it does that for every single one. So that's 15, we'll go down to 20. So if it's the 20th of December, tell me in Python shell it's the 20th, turn pin 2 on, turn pin 0 on, wait for a second, turn pin 2 off, 0 off, wait for 0.1 of a second. It's easy. This code is just copy and paste and just change numbers. I'll put it all in the description down below. It'll be in a GitHub repo, but make it accessible for you. Okay, what about 25th? Well, it's the 25th of December, it's Christmas Day. Merry Christmas. We're going to use that for loop again. So I equals 0, so we're going to set I to 0 again. And then lazily we're going to say, okay, for I in range 26, so from 0 to 25, turn the appropriate GPIO pin on for 0.2 of a second, then turn it off for 0.1 of a second. And that'll just like a chaser sequence. In fact, it's a sequence you're seeing right now. That's it. That's all it does. I like it. It's a nice little chaser sequence. So how does the code run? We're going to use a try and except. This is basically like error handling. It's going to try and run the code. So it's going to try and run a while true loop to continuously run. It's going to clear the LEDs. And then it's going to run the advent function with the day. So if it's day 1, it's going to show 1 LED lit. Day 2, it'll show number 2 LED lit. Day 15, 1 and 5 will light up. Day 21, 2 and 1. 21, I do feel like a bingo caller. Day 22, 2 and 2. 22, 2 little ducks. If something goes wrong, an exception, an error, it's just going to print uh-oh to the Python shell. Nice and easy, and this will auto run. So when I wake up in the morning, I'll plug in a USB power bank to this, and it will auto run, get the time and date, and show the LED lit. When it's bedtime at night, unplug it, save power, plug it back in the next morning, automatically does all the work for me. How does it do that? If you look here, top left, it says main.py. If you save your code as main.py onto the Pico or any other MicroPython device, it actually runs the code as the machine boots. So right now you're seeing day 25. I'm going to just slightly tweak it now so you can see what day 1 looks like. So I just change it to 25 to make it all razzle dazzle. So 1 moment please. So there we have day 1 flashing away. You can see number 1. So when I unplug this and then plug it back in on day 2, it'll light up day 2. When I go to day 21, it'll show 2 and 1 lit up together. Good bit of fun, 10 quid, you can pick one up now, you can solder it up and have a bit of hacking. Anyway, that's day 1 done. I'll see you tomorrow for day 2.